Alright, this is lesson 52 for 7th grade, and today we're talking about order of operations. This stuff I like a lot. It can get a little tricky if we don't follow this certain order that we're going to talk about. But just to sum it up, we're going to take a lot of basic operations that we do on a daily basis, and we're going to combine them. And what we're going to do is we're going to solve or figure these things out in a certain order, and the certain order will help us get to the right answer. Now if we mess up the order of how we do things, it's going to get us to a different point. So we want to make sure we follow the rules, and this is basically what we're looking at. It says, recall that the four fundamental operations of arithmetic are addition, subtraction, multiplication, and division. We can also raise numbers to powers or find their roots. When more than one operation occurs in the same expression, we perform the operations in the order listed below. So this is our order of operations. This is what we're talking about today. 1. We simplify anything in parentheses or symbols of inclusion. And we do that from the innermost to outermost before simplifying the outside of the parentheses. So anything inside parentheses, brackets, braces. Here's our little side note. Symbols of inclusion. They set apart portions of an expression so they may be evaluated first. The following are symbols of inclusion. So we've got parentheses, brackets, braces, and a division bar and fraction, which we'll see one of those too. When we do a division bar, we'll usually figure out things on top first and the things on the bottom, and then we'll divide in the end, and we'll show you what that looks like. Okay, 2, simplify powers and roots. Number 3, multiply and divide in order from left to right. So multiplication and division are on the same step. So it doesn't matter which one you do first, you follow it from left to right at that point. Addition and subtraction are also on the same step, and we do those from left to right. And we'll show you what that looks like. Just a mnemonic device that we can use here. The initial letter of each word in the sentence, please excuse my dear Aunt Sally, reminds us of the order of operations. So, please for parentheses, excuse for exponents, my dear, multiplication and division, Aunt Sally, and addition and subtraction, left to right. So it's a good way to help remember. The one that I used a lot in school was, we made up a word called PEMDAS, and we grouped these two together and these two together. So, please excuse my dear Aunt Sally, parentheses, exponents and roots, multiply and divide from left to right, add and subtract from left to right. PEMDAS, that's the one that we used. And it's stuck with me ever since high school. Alright, so let's actually take a look at how this would play out. First thing we look for, parentheses, or any other symbols of inclusion. I don't see any, so we move down to the next step. I don't see any exponents and I don't see any roots. Multiplication and division from left to right. Okay? I do see multiplication, so that's the first thing I see when looking left to right. This is addition. No, we're not there yet, so we do 4 times 3 first. We'll drop down this plus. 4 times 3 is 12. We've got this 2 over here. That drops down to minus. That's going to come down. And then we did our multiplying. 4 times 3 was 12. 4 divided by 2 is 2. Okay? Now we got rid of the multiplication and division. So we look at adding and subtracting from left to right. So we have to go from left to right. We don't want to do 12 minus 2 first. We want to do 2 plus 12. And that gives us 14 minus 2. And 14 minus 2 will give us 12. Okay, final answer is 12. 14 minus 2. Alright, so that'd be a very basic order of operations problem. They will get more difficult, and it's more fun that way. Okay, so now let's try this one. This one has a symbol of inclusion. It doesn't have parentheses, but it has this division bar. So what we're going to want to do first is, well, we've got nothing to do on the bottom. It's just a 2. So let's figure out everything on top first, and then in the end we're going to divide by 2. So this equals, what do we want to do first here? No parentheses. I do see an exponent though, 3 to the second power. 3 to the second power is 3 times 3, which is 9. So we got 9 plus 3 times 5. All over 2. Alright, no more exponents. We moved on to multiplication and division, sorry. And we do have multiplication. We have 3 times 5. That's 15. So we have 9 plus 15 all over 2. And our last step, we are now down to addition and subtraction. So let's add. We've got 9 plus 15. That's 24. So we've got 24 all over 2. And now we can actually divide. Now that might seem out of order, but we have to remember that a division bar is a symbol of inclusion. Okay? So we want to figure out everything on top, everything on bottom, and then we divide in the end. We want to make everything simplified on top and bottom, basically. Numerator and denominator. 24 divided by 2, get 12 again. Alright. We'll be going through a bunch of these tomorrow. Okay, now we have an evaluation problem. Now this comes into play with order of operations. We've done this before. If A equals 3 and B equals 4, evaluate this expression. Okay? Well, I'm going to plug in 3 for A. 3 plus 3. And this means A times B. B is 4. So now we have 3 plus 3 times 4. We have to multiply before we do any adding. So it's 3 times 4 is 12. 3 plus 12 is 15. Okay? We have another one here. Evaluate x times y minus x over 2 if x equals 9 and y equals 2/3. Alright, if x is 9, this is 9 times y, or 2/3, minus x over 2, that's 9 over 2. And we're going to have to do some multiplying first. So we have 9 times 2/3, or a little sidebar, do 9 over 1 times 2 over 3. Really, we could go, excuse me, we could do 9 times 2 and get 18, and that would be over 1 times 3, which is 3. So 18 divided by 3 is 6. I like doing the shortcut. 9 divided by 3 is 3. 3 divided by 3 is 1. So 3 times 2 equals 6. 1 times 1 is 1. So really this quantity right here equals 6. Now we have to do a common denominator to subtract. So 6 over 1, and we want a denominator of 2. Multiply that by 2 and that by 2. So we get 12 over 2. Just another way to write 6. 12 over 2 minus 9 over 2. And then we do our subtracting. 12 minus 9 is 3. So 3 halves, or 1 1/2. Like that. Alright? That one was a little more involved. So yes, evaluation, that will still come into play, and our order of operations will fit within that. Okay? a couple more things here. This is just to clarify why we have order of operations here. This is in the book. It says, why are the parentheses needed in this expression? Okay, well remember that parentheses tell us that we're going to do this first. If the parentheses weren't there, it would look like this. Now let's see what answers we get. This one says add 3 plus 7 first. So we get 4 times 10. 3 plus 7. 4 times 10 is 40. Without the parentheses, we multiply before we add. 4 times 3 is 12. 12 plus 7 is 19. So that's why the parentheses are important. It tells us we want to add these first. Okay, so that's why the order of operations is so important. Okay. Last slide here. Just to point out, let's see my time here. Alright, we'll wrap it up here. Just so we know, calculators. They have, well, don't rely on your calculator too much, I guess is my point here. You have to know what you're typing in. They are designed, most of them anyway, to follow order of operations. But a lot of times if we type in things all at once, it doesn't really like, it doesn't always like the format that you're going to want to type it in as. A lot of times you'll see on the power up that we do every day, if you try to type in every single step on our letter H usually has a lot of different operations to follow. If you try to type all of it in at once, your calculator will give you a decimal, and those usually don't come out to decimals. So just a heads up that if you're going to use a calculator, don't try to type everything in all at once, because if you have to do that, or if you try to do that, it can get really messy. If you want to kind of see the correct way to do it sometime, just ask me and I can show you. But it actually takes longer, I think, to type in everything rather than just figure it out with paper, pencil, and in your head. But like I said, we'll cover more of this tomorrow, go through a bunch of examples, and we'll see how we do with it.